Welcome back yet again for even more Python for beginners. This time we're going to focus in on data libraries. Now, if you haven't seen any of our videos before, well, you should definitely go check those out before you check this one out. But let's start off by getting in, doing some basic introductions, and answering three questions. Who are we? Who are you? And what is it that we're going to be doing today? So let's start off with that first question. Who are we?
Great. So my name is Susan Ibach, and if you've seen our other videos, hi again. And I'm the CEO and head geek of Hockey Geek Girl Incorporated, instructional designer. I am a data geek. Data is my happy space, so happy to be talking here about some data today. And I'm also a mom, a marathon runner, and a thrash metal fan.
And as for me, I am Christopher Harrison. I'm a longtime geek. I started actually when the VIC-20 came out, sort of really dating myself with that little reference. I'm a program manager inside of academic ecosystems. I have a propensity to tell dad jokes as well as the propensity to say the word propensity. I'm a husband, I'm a marathoner, and I'm a father, if you will, of a four-legged child, also sometimes known as a dog. She's an adorable little black and white, sort of like Amstaff mix. But anyway, so who are you then? Well, here's what we're assuming. We're assuming that you've done some level of Python and that you're maybe looking to explore, like some data science articles, I think would be the best way to describe this. That you might be going, hey, there's a neat little quick start here. It walks me through going in, setting up a basic little model, and like predicting a value, or seeing whether or not somebody's gonna buy a bike, or something like that. And you're trying to go, hey, well, what does this code mean? What are these libraries? What are these classes? What are these objects? What are those things? And that's what we really want to try and show off to you.
Yeah, we want to help you get to that point so that when you're going through those data science tutorials, you can focus on learning the data science in those tutorials and hopefully have a slightly higher comfort level with some of the code that you might encounter when you're looking at those articles.
So then to support that, what we're going to do here today is introduce some of the common libraries and things that you're going to be using, and some of the common tools and techniques, things like Jupyter and data frames and so forth, that are really going to, I'd say, lay the foundation for what is going to be your journey, your adventure into data science.
Yeah.
So if you're ready, I think we're ready.
I think we are.
Then
I think we should do some code.
Yeah, let's get into it. One of the things that you're going to notice when you start getting in and playing around with data is the fact that you're going to work very iteratively, that you're going to try a couple of things, go back, make a couple of changes, try it again, go back, make a couple of changes, try it again, and so forth and so on. And the problem with doing that with kind of more traditional tools is the fact that you oftentimes have to set up like a little bit of scaffolding and getting to the exact spot of code that you want to be able to run can be a little bit clunky. And so this is where Jupyter comes into play. So what I want to take a look at here is the concept of Jupyter notebooks and where it is that you can set this up, where it is that you can run this, etc. So Jupyter is an open source platform or framework, if you will, and really what it's there to do is to give you an integrated development environment. So that way what I'll be able to do is maybe do a little bit of prereq work, get to the exact spot that I'm wanting to play with, and just keep going, doing whatever it is that I need to do in here. Once I've got that done, then I can move on to the next block, and maybe I need to go back and make a couple of changes, and then run back down, and so forth and so on. And that's what this is all going to enable. Now you are going to notice that you could install Jupyter locally on your system, that if you head on over to jupyter.org, you can download and install Jupyter, get it up and running, and actually get the browser experience that I'm going to be demoing for you in just a couple of moments, running locally on your system. Now, I'd be remiss if I didn't highlight the fact that Visual Studio Code also has a wonderful integration for Jupyter Notebooks as well. So if you really like to use Visual Studio Code, you want to stay in that environment, then you can also configure Visual Studio Code to give you the ability to run your notebooks as well right there inside of the editor, which is personally one of my favorite little things inside of VS Code. If you check out the GitHub repository that's part of this course, you'll see a link to how you can go in and set all of that up. I also want to highlight, and this is what I'm going to be using for my demo, the fact that you can run Jupyter in the cloud. And there's a couple of different ways that you could do this. In my case, I'm going to do it by utilizing the Azure DSVM or Data Science Virtual Machine. And what the DSVM is it's a virtual machine, as you might expect, that has a whole bunch of tools already installed. And it's like perfect for getting in and playing around with data, that most of the things that you would need, including Jupyter, is going to be right there in that nice, neat little package. All that you have to do is just say, yes, I want this, and then create it, and away you go from there. And once again, we'll have the instructions on how you could set that up inside of the GitHub repository. Let's check out how we can use Jupyter to start playing around with some code. So what I've got here is the Jupyter Hub set up inside of my DSVM, my Data Science Virtual Machine. And I've already got a few different folders and things like that come just pre-built inside of there. But what I want to do is play around with a brand new one and start creating some notebooks inside of there. So what I did is I hit New right up there on the top right. And what you're going to notice is I've got the option to hit Folder. So I'm going to create a brand new folder here. And you'll notice that it will just automatically give me this new little folder right here called Untitled Folder. In order to rename that, it's an additional step here that I need to hit the little check and then come up here, hit Rename, and now I can give it my very creative name of Demo. So now I hit Rename. Now you're going to notice that it's set up as Demo, and now I can click on that link, and now I can start creating the different items that I might want inside of here. Now, it's worth highlighting the fact that inside of here, I can have things like CSV files, images, and anything else that I might be using as part of the manipulations and work that I'm going to be doing. But the real center to everything that we're going to be working with is a notebook. And so you'll notice once again that I hit New, and then there's a whole bunch of pre-configured options for me for different notebooks. And what I really like about this is that if you want to use, say, for example, R, that I've got that option right there. If you're wanting to play around with Scala, you can do that. Both R and Scala, by the way, are languages that are very popular when you're working with data. Or I can also go in and choose my different Python notebooks as well. So what I'm going to do is I'm going to hit Py37 default, and that's going to set up a brand new notebook for me that is just simply Python. Now, in order to make this function, there's always going to be a kernel. And you might have noticed, like right up here, there was a little thing that was going on right up here where it was telling me that it was creating a kernel and setting all of that up. That's my runtime behind the scenes. And so if you want to go in and play around with that little runtime that's making it all happen, then you can hit the kernel window, and then you can choose to, say, restart it. You can reconnect in case something maybe has gone wrong, or maybe you open this up from somewhere else. You can restart and have it rerun everything inside of your notebook. And then last but not least, you'll notice right here that you have the ability to restart and clear output. one big thing to note about the notebooks when you're playing with them, and let's say I maybe load up some data and I manipulate it and I get a result, that actually becomes part of your notebook. So you can refer back to this with the answers, if you will, already in place. If you want to start all over again, that's where that clear output comes into play, so that way it will just get rid of everything and allow you to redo whatever it was that you were working on. Now, I also want to highlight in here one very important spot, and that is that little square bracket placeholder, if you will, that's right there. And that will indicate one of three different things. If it's blank, like it is now, what that's going to indicate is that whatever is in that cell has not run. Now, if it is running, then what will happen instead is there'll be an asterisk inside of there. And it's hard for me to get like a real big asterisk using the tool, so you can sort of see it's there. If you see an asterisk, what that means is that it's executing. It's currently running. The last thing that you'll notice is a number in there. And what that number is going to indicate is the order in which that cell has executed. And that becomes important because even though the cells are going to go top to bottom, the order of execution doesn't necessarily need to be top to bottom. And that can actually help you out sometimes. Let's say I'm all the way down towards the bottom. I've got a lot of work that's been going on up here. I try to execute this one little line of code, and then I forgot to do something. Maybe I forgot to load up a library or to run one last little line of code. Well, then what I can do is just create another cell down at the very bottom, run that one little line that I need, and then go back up and then rerun that cell. So it gives you a lot of flexibility there, but you just have to be careful to make sure that things are executing in the order in which you expect them to execute. So let's play around just a little bit here. I'm going to go ahead and say name equals Christopher, and then I'm going to say print name, just like that. And now I can run my cell. There are buttons to run the cells. You can go in and explore the buttons on your own. I'm going to be honest with you, I never remember what the buttons are, because there's really just two shortcut keys that you need to know. Control-Enter and Shift-Enter. Watch the difference. What I'm going to do here is I'm going to hit Control-Enter. And what Control-Enter will do is it will run that cell, and that's it. It'll just run that cell, stay there, and we're done. Contrast that with Shift-Enter. So now I'm going to hit Shift-Enter. And now what I want you to notice is it still ran the cell. You'll notice the number changed from a 1 to 2. But now I get a brand new cell. When I use Shift-Enter, what's going to happen is it will run the cell, move to the next, and if there's not already one there, then it will create a brand new one. One other really cool thing about Jupyter Notebooks is the fact that if I just want to see what's inside of a variable, then what I can do is just end my block with it, run it, and then it will just display whatever's inside of there. And what's really cool about that is the fact that you'll be doing all sorts of really cool things inside of your notebook, and then I just want to see what's inside of an item. Just end your code with it, and it will print out whatever is inside of there. It's probably my favorite feature inside of Jupyter Notebooks, because quite frequently you're going to be working with different pieces of data. You're not going to necessarily know what's going on. You just want a real quick sneak preview of what's going on. Jupyter is there to help you out. The last little thing that I want to mention is I can also change my cell type to be Markdown. And now I can use Markdown inside of here. And so this is, if I can spell world, there we go. This is a great way to leave myself. Apparently I'm not able to talk and type at the same time today, but that's all right. Some notes, just like that. So that way I want to indicate anything else that might be going on inside of here, then I can just do that with Markdown. Now, Markdown does behave like a normal cell, so you'll notice that it's in edit mode here at the moment. but when I do like a Control Enter just to run that cell, now you'll notice that it will put it into kind of a more proper display here. So maybe what I could do is I could move that cell up. I'm just hitting those little arrows right up there, up to the very top. So now I've got that as part of my hello world. So there's sort of the quick version, if you will, of getting in and working around with Jupyter Notebooks. There's an awful lot of power and tooling inside of there, but that's probably the most common tools, the most common options that you'll be using when you get in and play around. This is going to be the core of all the demos that we're going to be doing in this course. Everything that we're going to do is going to be done inside of our Jupyter Notebooks. And I again want to highlight the fact that you could run this in the cloud like I am with a DSVM. You could run this locally, and you could also do this inside of Visual Studio Code. And again, you can check out the GitHub repository for links on how to do all the installations and how to set up Visual Studio Code.
Christopher just took you through some of the things we can do with Jupyter Notebooks. Now, one of the challenges you're going to work with when you start playing with Jupyter Notebooks is some other tools you might need to work with as well, specifically Anaconda and Conda. Anaconda is an open source distribution of Python and R that's often used for data science. When you install Anaconda, it comes with about 1,500 different packages that you can use. It has this graphical interface called Anaconda Navigator. It also has a command line interface called Anaconda Prompt, and it also comes with a tool called Conda. So Conda is a tool that you can use to create and manage Python environments. Now, back in the original Introduction to Python series, we talked about how we could use virtual environments to manage all the different packages we work with when we're coding in Python and the different versions of Python. So that becomes important with notebooks as well, but we tend to use Conda when we need to manage packages and environments for Jupyter Notebooks. So what you're going to want to do is install Anaconda, and then after you've installed Anaconda, you just launch the Anaconda prompt. And then to create a virtual environment using Conda, you use the Conda create command, you give your environment a name, and you specify the version of Python you're going to be running. The -y there is simply a way of saying if you ask me questions to confirm as it's running, just answer yes to the questions by default, just so you understand what that little -y is doing. So you just have to come up with a name for the notebook and know which version of Python you want to work with. Once you've created the environment, then you can activate it. So you simply call Conda, tell it to activate your notebook. A couple of other useful commands you might need down the road. If you need to deactivate your environment to move back and forth, you have Conda deactivate. And if you no longer need an environment, you can delete it by using the Conda remove command. Once you have activated an environment, so you create an environment, you activate an environment, then you can install the libraries you're going to use inside that environment. So we can install pandas. You might be installing things like Matplotlib, Numpy. These are some of the libraries you're going to start getting to know if you start exploring that world of data science. So you may need to install them. Otherwise, what will happen is when you're running Jupyter Notebooks, you're going to see error messages coming back saying, I don't know what Matplotlib is. So this is how we're going to fix that problem. After you've installed the libraries that you need to use for your code, you're also going to install Jupyter itself for the Jupyter Notebooks. If at any point you lose track of which libraries you've already installed, you can always use Conda list to get a list of all the installed libraries. Once you've installed what you need, you can simply launch Jupyter Notebooks from inside the active environment, and now your code should be able to access all the libraries you need to do your coding. A couple of little tips that might be useful. I've run into this before. When you're back in the command line environment and you've launched Jupyter Notebooks and you want to go back and maybe install an extra package, Control-C will take you back to the Anaconda prompt. And sometimes after you've installed a package, I find it doesn't seem to recognize it right away when I launch the Jupyter Notebook. When that happens to me, I usually find if I deactivate the environment and activate it again, it usually works. Doesn't happen often, but it's something you can try if you run into that issue. All right, let's try it out. Okay, so we just talked a bit about how to create virtual environments and why they're important. Let's take a look at that in some actual code. So I have here a Jupyter Notebook, And one of the things we often do when working with Python is import different libraries, pandas, NumPy. You'll see some of these as we go through this course. Now, in this case, I have one where I'm importing something from Matplotlib. This is another library we're going to play around with later. And when I run this line of code and try to import the library, I get an error message saying, cannot find the module Matplotlib. This is probably the #1 error message you're going to get used to seeing when you're working inside Jupyter Notebook. So we want to learn how do we deal with that message when it comes up. When we did the Intro to Python course with Christopher, we learned how to work with virtual environments, but with Jupyter Notebooks, we usually do this with something called Conda. So if I close this down, you can see here this was actually the Conda environment I was using, but we aren't going to be using that one because it was giving us an error message. So if we have launched the Anaconda prompt, you can see right now I'm in the base environment because of the word base appearing here. So what I'm going to need to do is create a new virtual environment. So I'm going to tell Conda I want to create a new environment, and I'm going to give it the name Python environment. And it's going to be a Python environment with Python version 3.7. And I'm just putting a -y here. So if any prompts come up asking me questions, it will simply automatically answer yes to those types of questions. And now it's going off and creating this virtual environment for me for Conda. Once I've created that environment, I can then move to that environment by saying Conda activate. And it's even nice, it gives me a little hint here in case I forget the commands. Activate my environment, which I called Python env. Remember, this is just the name I gave to the environment. Once you've activated that environment, you'll even notice that the prompt will actually show you the environment name, so you can remember that you're in your virtual environment. And now I can install any of the libraries I might need to use when I'm writing my code. So in our case, we were getting an error trying Matplotlib, so we can say, hey Conda, would you please install Matplotlib for me? And so now it's going to install that library so that I'll be able to access it from inside of my code. Now, once we've installed the Matplotlib library, you might have other libraries you'll need to install as well, depending on what you're trying to do. But there's one extra library you always want to install. And that one, so maybe you install pandas, maybe you install NumPy, but we definitely want to install one called Jupyter. So we actually want to install Jupyter, which is what runs the notebooks, inside our virtual environment. Because that way, when we run the Jupyter notebooks, we know the Jupyter installation is actually using the libraries that we have installed inside this virtual environment. Once the notebooks have been installed, then we're actually going to launch Jupyter notebooks from the actual Anaconda prompt itself. So this time, when I say run Jupyter notebook, I'm launching Jupyter notebooks from inside my Conda environment, Python env. And this time, when we navigate to our notebook and we go to that line of code where it couldn't find Matplotlib, we're going to see that line of code is going to run successfully. So you get a little peek behind the scenes here at Susan's, all the various notebooks Susan has created for this course. But if I go back to the one where we had imported Matplotlib, you'll see here before it was giving us an error, but now when we run that line of code, it runs successfully. So no more errors. So now when you're using your Jupyter notebook and you get that error message saying, hey, I can't find that library, you know how to create a Conda environment, install your libraries there, run your Jupyter notebook, and get it going successfully.
As mentioned on the outset, what we're going to focus in on is some of the common libraries and tooling that you're going to use when it comes to working down the path of data science. And so along those lines, we're going to take a look at a really common library known as pandas. Now, sorry to disappoint right up front. Sadly, this has nothing to do with the bears. I know I was disappointed when I first found that out. But rather, it's a library that has a couple of very common utilities that you'll be using to help work with, manage, and manipulate the data as you start to analyze it. So what is Pandas? Pandas is an open source BSD licensed library, and it's really geared towards high performance and familiar data structures. That what you're going to notice in here is that we're going to have a series library that's going to be a little bit like a list, only gives us a couple of additional tools as well. And we're also going to see a data frame where if you've played around with Excel or maybe a relational database, that you'll feel very comfortable inside of a data frame. So first up, what is series? Well, series is very similar to a Python list. That what it's going to be is a single dimensional array of objects where I have all of my values sitting there, and they'll have some form of an index. One big difference, however, between a series and a list is the fact that we can set our index to really be whatever it is that we might want. By default, it's going to be zero-based, but if you do need some level of control over that, you can have that as opposed to an index, which is always going to be zero-based. Now, to create a brand new series, what you're going to do is use the constructor. So if you've already played around with classes before, you'll know that you go ahead and call this just like you would a normal method, and then pass in the appropriate items. And you'll notice that when you get right down to it, what we're doing here is we're really actually just converting in a list into a series. So you'll notice the square brackets here. That's what we're using to indicate a list typically. So we're actually converting this into a series. The other thing that I want to highlight here is you'll notice this little PD right here. And you might be wondering, okay, well, what is PD? Commonly, when you import in the Pandas library, you'll rename this as PD, PD being short for pandas. Now, if you've seen me do other videos, you may know the fact that I really don't like single and 2 and 3 letter variable names or otherwise. That to me, it's just not, it's not necessarily as clear as to what it might be. That being said, I will always go with convention. So convention always overrides my own personal opinion because, well, I have opinions on everything. But the community has decided that when we use pandas, that we'll go ahead and abbreviate this as PD. And so I follow right along with that. And I do recommend that you do the same, that whenever there's a convention, you should go ahead and fall in line there. Because after all, it's not just going to be you that will be looking at your code, but it's frequently going to be other Python developers as well. And you want to make sure that they know what it is that you've been up to inside of your code. So while I'm not necessarily a fan of 1 and 2 letter variable and namespace names, I'll still go ahead and use PD because, again, that's the convention. So you'll notice here we can go ahead and set all of this up. When we go ahead and display this, it will then show up as just simply that little list right there with the index. And you're also going to notice that if I want to go access a particular item, I can use the normal index functions. So here is my airports with 2, just like that. I can do a for loop to loop through each one of those. So if I print all of those out, you'll notice that I'll get Seattle Tacoma, Dulles, London Heathrow, and Schiphol down at the very bottom. Okay. Let's turn our attention now to data frames. And I would say that this is probably the most common data type that you'll be using when you're getting in and playing around inside of anything that's data science-y. A data frame is a 2-dimensional data structure. And if you've played around inside of a database, if you've played around inside of a spreadsheet, you're going to feel very much at home here. Because what you're going to notice is that we have columns and we have our rows, and our columns are going to have names. So you'll notice that we've got name here, we've got city here, we've got country all the way on the end there. We've got our normal columns just like we would expect. You're also going to notice, again, kind of similar more to a database than maybe to a spreadsheet, that will also have a column that will be our index. And you'll also notice that you'll have the ability to control that By default, it's going to be 0 based, but if maybe I'm importing in from somewhere else, maybe from a table, maybe from a CSV file, maybe there's already IDs that have been set, that I could go in and identify, hey, this is the column that I want you to use as an index, rather than doing the 0 based there. So you do get the ability to control that. If you want to create a data frame, what you're going to notice is that we'll use, again, a constructor, but effectively we're going to convert a list of lists into our data frame. So I want to highlight just this item right here, where you'll notice that we've got Seattle-Tacoma, which is the name of the airport. You'll notice that we've got the city, which is Seattle, and then we've got the country, which is USA. And then you'll notice the next list down below that, I'll highlight that one in blue here. And you'll notice on that one that we've got Dulles, we've got Washington and USA. So again, we've got the name of the airport, the city, and the country. So each one of those is an individual list. We're going to take all of those together, convert that into a data frame, and the result is going to wind up being that little table that you're seeing right there. So you'll notice that Seattle-Tacoma, Dulles, London Heathrow, Schiphol, and Shanghai all become our individual airport names. Just imagine, if you will, that Shanghai was added onto there, even though it just wasn't listed in the code above. You'll notice the cities, and then you'll also notice the countries. So what happened is we took those lists and we converted that into a table structure. But what I also want you to notice is the column names there. The column names are, quite frankly, not overly helpful. That I got column names of 0, 1, and 2. 0, 1, and 2 don't tell me anything. And not only that, but dealing with data where everything depends on position can get really tricky, because you have to be really careful about things moving around and so forth. So whenever we can identify something based on name, that's typically going to be the way that we want to do it. So rather than going with those numbers that we see by default, let's instead identify what our column name should be. So you'll notice the last parameter there, which is our columns. So now when we run this bit of code, now we'll actually wind up with the column names. So you'll notice that we've got name, we've got city, and we've got country. You're going to notice that there's a lot of tools that are available to us inside of the data frame. And we're going to take a look at those in the next couple of videos. But for now, this is how we go in and create the items. Let's get in and take a look at a couple of real quick code demos so we can see this in action. Let's take a look at a notebook where we've got a little bit of code that highlights what it was that we talked about previously. So what we're going to notice here is we're going to start off by loading up our pandas library just as we normally would in Python code, because again, obviously we're writing Python, by simply saying import pandas as PD. Now, I'm actually going to leave this behind for just a second here. I actually want to do things out of order, and then I'm going to double back. So what I'm actually going to do is I'm going to run this line of code right here, where I'm trying to use that pandas library. And what you're going to notice, of course, is that it's going to give us an error message saying, hey, I don't know what PD is. PD is not defined. The reason that it's not defined is because, of course, we didn't run that little line of code right up top. So let's run that. So I'll do a real quick Shift-Enter. That will actually move me down. You'll notice now I can see the little number 2 right there. That tells me that this is run. And so now I can keep on keeping on and create our little basic series here. So when I run this, what you're going to notice is my output here is going to be my data type. It's telling me the data type that's inside of there, object, or string really. And you'll notice my index over here of 0, 1, 2, 3, 4, 5, and 6. You're also going to notice that cool little trick that we talked about previously, where if I just put a variable or some operation that's going to return back a value at the end line inside of a cell, that it will just simply print that out, boom, we go ahead, we have airports, and that will just go ahead and print that out right there. And that's something I find myself doing quite frequently, because especially when you're dealing with data that you've loaded in from somewhere else, maybe you've done a couple of manipulations on it, now you want to see what the updated values are, you want to see maybe whether or not you did things correctly, you know, those types of things. It's a very quick and easy way that, that you can do that. And it will just simply print out. If I want to go in and access a particular item, then I can do that by its index. So we'll go grab 2. That's of course going to be the third item. All counting starts with 0. So that's going to give me back London Heathrow. And then you'll also notice that I could loop through all of the items, do a real quick print, and then you're going to notice that it gives me all of the values back. I do want to do a real quick aside here. And I want to point out one subtle little thing that I'll sometimes get asked when I'm doing notebooks here. That you'll notice that up at the very top with London Heathrow, that I've got the single quotes there, kind of indicating the fact that it's a string. And then you'll notice down below that I don't get that I just simply get the string without the single quotes. And you might be wondering, well, why the difference there? What's happening? And what's happening there is effectively what's in charge of displaying something out on the screen. When you use print, print is going to write something out to the console. And print has its own way of writing things out to the console. And in this case, my notebook is playing the role of the console. So we're seeing really the exact same output that we would see if we were running this locally. So no single quotes or anything like that. It's just simply writing out to the console. That's the expected behavior, and we're done. So it's not my notebook that's printing it out, but rather really it's print that's in control of how that's going to be printed out. On the flip side, however, if I just simply do this, where I'm executing a little bit of code, that's what I'm doing there. I'm saying airports and then my indexer of 2. I'm executing a little bit of code. That code is then going to return back a value to me. In that case, it's now going to be Jupyter that's in charge of printing that out. And that's why we're getting the little string there, because it's indicating to me, giving me a little bit of a hint there of the data type as well. So it's showing me, hey, this is a string, and that's why I'm seeing those single quotes there. So to distill all of that down, the difference between those two is print is just in charge. It's printing out all of those values, as opposed to just executing a little bit of code that's giving me a value back. When the notebook is in charge, then it's the notebook that's going to determine how that's going to be output. And the people who did up Jupyter and put all of this together decided, hey, we also want to indicate to you the data type, and that's why you're getting the single quotes there. So if you were curious, that's what's going on. All right. Back to our regularly scheduled programming here, let's take a look at a data frame. So now what we're going to do is execute the exact same bit of code that we saw on the slide. What you're going to notice is that we've got our list of lists. So we've got right here Seattle, Tacoma, Seattle, and USA as a list. Each one of those entries is now going to become a cell inside of a row. And so when I run this, you're going to notice down below that now, there we go, that is now a row as promised. And then you'll also notice that each of the first entries then becomes a column. And then you'll notice my column names are the rather unhelpful 0, 1, and 2. If we have the opportunity to name something, we should almost always take that opportunity. And so that's what we're going to do right here, is we're going to indicate, hey, let's put in some columns here. So let's identify the first one as name, the second one as city, and then the third as country. So now let's go ahead and run that. And now you're going to notice the output there with our name, our city, and our country. Okay. As I highlighted towards the end of the last little video there where we were introing all of this, there's an awful lot that we can do with data frames. This is how we can go in and create them. In the next section, we're going to take a look at how we can start to manipulate them a little bit and start to see what's going on inside of them. When you're working with data, you're typically going to be importing this in from a database, from a CSV file, from somewhere else. And when you're pulling that data in, the first thing you'll typically want to do is figure out what it is that you have. Because real-world data is messy. There's going to be errors, there's going to be inconsistencies, there's going to be missing values, etc. That before you begin performing any operations on the data, you first need to figure out what in the world you've got. So fortunately, what we're going to notice with the data frame is that we have a lot of different ways that we can explore our data. Now, like we did in the prior module, we are going to hard code in what our data frame is going to be, just to make things a little bit easier. Don't worry, however, we are going to show off the code to actually load this up from a CSV. So how can we go in and explore this? And again, there's a whole host of different ways that we can do this. A couple of the most common are head and tail, where with head, we can indicate the number of rows from the top that we want to be able to see. And with tail, as you might expect, we can see the number of rows from the bottom that we want to be able to see. So head 3 is going to give us the first 3 rows. Tail 3, of course, is going to give us the last 3 rows. We can also find out what the shape is, or basically what are the dimensions. Or in other words, it will give us the number of rows and the number of columns. So if we take a look at the output here, what we're going to notice is 7 for the number of rows, and then 3 for the number of columns. Now you might be thinking, well, wait a minute, Christopher, I'm counting 4 columns because I see index and I see name, city, and country. And you're right. What the 3 is actually indicating to us, because there will always be an index, is the number of data columns that we have. So 3 is the number of data columns, 7 is going to be the number of rows, 0 through 6. Of course, that's going to be 7. So that's the shape that we're getting back. But shape is really kind of a high-level thing. It's nice to know what it is that we're dealing with, but sometimes we need a little bit lower level of information here. And this is where info comes into play. With info, we can get an awful lot of what's going on inside of our data. So what we're going to see when we run info is the number of rows or entries. We're going to see the index range, so 0 to 6 in our case here. We're going to see the number of columns. We're going to see the information about each column, including the names, whether or not any of them are null or not null. So it's going to show us the non-null values, so you could extrapolate there how many null values that you might have. And then it's also going to indicate the data types. Keep in mind that a string is an object in this parlance. So by using head, tail, size, and info, I can get a little bit of information about what's going on inside of my data frame. Let's now turn our attention to the code that actually makes all of this magic happen. Let's see how we could explore a data frame using a little bit of code. So let's first, again, import in our pandas, and let's create that data frame. Now, you might be wondering, hey, why in the world would you start exploring a data frame when you've hard-coded in what that's going to look like? And again, you're exactly right. We're going to show a little bit later how we can load up some data. We just want a simple data frame that we could start to show off some of these skills, so that way when it comes time to load up some data, that we know better of what's going on and how to start exploring all of that. So there we go. I'm just going to create my data frame. There it all is. And now let's explore it. So like we mentioned before, head will give us the ability to see the top 3 rows because I specify 3. If I specify 2, for example, as you might expect, that's going to give us back just simply those 2 items. 5, I think you start to see where all of this is going. It will just give you back that number of rows. If you want to start from the bottom, then you could simply use tail, and that will just count up from the bottom. So if we take a look, you'll notice that there's our the bottom of that, so Narita, Pearson, and Shanghai. And if we take a look over here, we can see back in our original data frame, that's exactly what we've got there. And if I just want to see what's the shape, what does it look like, 7, 3. Again, remember that the 3 is giving us the number of data columns, so it's not counting the index. And then finally, I can see the full info of that. So I can see the columns, I can see the names, I can see how many items in there are not null, etc. And I would say of all the information that that's going to give you, the not null is probably going to be one of the most important things, because working with null values can really be a struggle, because sometimes they'll indicate that there's just missing data, sometimes they'll indicate a condition. When you start doing math with them, things start to go sideways very quickly. Null values are really a struggle, so being able to see real quickly, hey, what does my data look like, is going to be really powerful. And it really is going to be probably the first thing that you will always do when you load up some data, especially data that you're not overly familiar with, to see what it is that you're working with. And now you've got the tools to be able to do that. Now that we've seen how we could grab some rows from our data frame, get the overall structure of it, let's get in and see how we could start to pull out different pieces of data. Now, you're going to notice about a data frame the fact that there's a lot of different methods and tools and so forth that are at your disposal for getting in and finding basically anything that you might want, performing all sorts of different manipulations and so forth. And we're going to take a look at a couple of these as we go through the next handful of videos here, but I want to stress the fact that we're not going to go through everything. If you go check out the documentation, linked to from our GitHub page, you'll be able to see everything that's available to you and begin to kind of just continue to grow your tool set. But let's get in and see how we can identify individual items or start slicing and dicing our data. So how can we go grab specific rows and specific columns, or how can we slice and or dice our data where we're grabbing full columns, full rows, etc.? Well, one way that we can do this is by grabbing a specific column by identifying it based on its name. That you'll notice that the indexer for data frame is going to, by default, be the name of the column. So if I say airport city, that's going to give us back everything that's inside of that city column, as well as the index. So when I do that, boom, I've got my city and I've got the index to go along with that. How about if I want 2 different columns? Well, if I want 2 different columns, then what I need to do is I need to actually pass in, where is my cursor here? Let me put that to red. There we go. Now I can find it. There we go. So what I can do is I can create a list, like I've got here, with the name of each column that I want. So you'll notice that I'm identifying my name and my country there, and so those are going to be the 2 columns that I want back. The main thing that I want you to notice about the syntax here is the fact that we're putting this inside of a list. If we didn't put that inside of a list, then what we're actually doing is passing in different parameters into that indexer, and that's not the way that it behaves. We want to pass in one parameter. That one parameter is going to be a list. So that little bit of square bracket that you're seeing inside of there, that's got to be there. So that way we can identify, hey, these are the columns. Cool. So that's how I could get individual columns. Now, let's say that I want to go in and grab things based on their position. that sometimes I'm going to have the name, sometimes I'm going to have the column, that maybe what I'm trying to do is loop through things. Maybe I want to see where something is specifically inside of a data frame. Maybe I do happen to know the location, and so that's what I want to be able to go in and do. And this is especially helpful if maybe I want to specify a range of columns or a range of rows. So what I can do is I can use my I location or my index location. There we go. With my I location, my index location, now what I can do is specify the rows and the columns by index that I want. So if I do 0, 0, like I've got right here, as you might expect, that's going to give us right here, Seattle, Tacoma. And so if I run this code, if you will, on my slide, that's what we're going to get back. If I say 2, 2, that's going to count down again, 0 base, so 0, 1, 2. It's actually going to give us the third and the third. That's going to give us, in this case, United Kingdom. Now, you might notice on the slide, and this will be true on the next couple of slides as well, that little spot right up there, that column 0, column 1, column 2, those are not actually part of the data frame. They're just there to help make our demo a little bit easier here. So that way you can see where 0, 1, and 2 actually are. So 0, 0, Seattle, Tacoma, 2, 2 is going to give us the United Kingdom there. You can also go in and specify a range. And this is what I was mentioning before, where things are actually a little bit more powerful when you're using that index location, is the ability to specify a range of values. So similar to using a range on, say, a list, where I could go in and specify 1 colon and then whatever my end index is going to wind up being, maybe for example 4, I can do the exact same thing here. So let's start off by using colon and colon. When I pass in those ranges on either side, or in this case, both sides, what I'm indicating is that I want all of the values from my rows or my columns. So if you remember from before, the first parameter, that's going to indicate the rows that I want. Second parameter, that's going to indicate the columns that I want. When I say colon and colon, I'm saying all rows and all columns. So if I ran this, I'm going to get back that highlighted section there where I'm going to get everything. If I said, hey, I only want, in my case, the first 2 rows, so it's going to be 0, 1, and then stopping at index 2, but not including it, then I could go in and specify that as my range. This is now going to indicate that we want back all of our columns. So if I run this, I'm now going to get back Seattle, Tacoma, Seattle, USA, and Dulles, Washington, USA as my values back. So first 2 rows and all columns. I could go the other direction as well, where maybe I put that over on the column side. So now that's going to give me back the first 2 columns. So that's going to give me back the name and the city. And we get our index as well. How about if I want to specify a list of items there? So maybe what I want to get back is I want to get back the first column and, in my case, the third column. Remember again, counting starts at 0, so 0 and 2, column 0 and column 2. The way that I can do that is by specifying a list. And I want to highlight here the difference between a range and a list. My range allows me to specify the starting point and the end point, whereas my list here is going to give me the ability to specify the individual items that I want here. So in my case, I want the first column and I want the third column, so 0 and 2. There we go. I'm going to specify 0 and 2. Those are the columns that I want back. You'll notice the colon at the beginning. That's going to specify that we want all of the rows. So if I run this, now what I'm going to get is my name and my country, and again, the index as well. If you want to do this by name, then you could just simply use location, so just LOC, and now if I specify name and country, that would give me back the exact same, but only doing it by name instead of by the index. All right, well, now that we've seen a little bit of a slide representation, what do you say we see this in action? Let's open up a notebook and see how we can actually use these tools. Let's see how we can find certain items inside of our data frame. So just like before, I'm going to go grab our pandas library, and I'm going to set up our data frame. And you'll notice just like before, we've got name, city, country, and all of the airports that are inside of there. If we want to go find a specific column, the simplest way to do this is just to use that indexer. So you'll notice that I pass in the name of city, and that will give me back the city, just like that. If I specify country, then it will, of course, give me back the country, and it's always giving me back that index as well, which honestly I like, so that way I can always find a specific row if I need to later. If I want to go grab particular items, then what I'm going to do is put that inside of a list as that parameter. So that's going to give me back my name and my country here. You'll notice one more time with our notebook, the fact that if I just execute the code, then it will just print that right out for me, which again, one of my favorite little things with notebooks. If you happen to know the index location, then you can do that. So to get whatever the first cell is, I can do that with 0, 0. To go get it over at 2, 2, then I can do it that way. Now, most commonly, the way that you're going to be using this index location is to go grab multiple columns or multiple rows. So if I want to specify a range, then I can use that colon, comma, colon. It's indicating that I want all rows, all columns. Boom, there we go. And if I want to indicate the start and end, then I can do that by using, in my case, 0 and 2. This will give me back the first 2 rows, or in turn, the first 2 columns, if I so desire. If I maybe want to go grab the second and the third, make sure that you indicate the ending index. Remember, it's going to go all the way up to, but not including. And so now what I'm going to get back is 1 and 2 here, which is what we would have expected. So it behaves just like a range for, say, an array or for a list. If you want to specify individual items, so maybe I want the first and the third back column-wise, then I can do that by specifying that little list that you see right there. So 0, 2. This is going to give us back columns 0 and 2, or the first and the third. So when I run this, it's going to give me back name and country. If I sneak all the way back up to the top here, there we go. We'll notice name and country is our first and third. So that was exactly what we got back. And if you want to do that same thing, but you want to do it by name, then you could use location. Again, that second parameter is going to be the column. So name and country is going to give me back name and country. Just like that. We get the same things. Cool. All right, so that's kind of a real quick primer, a real quick starting point for going in and working with our data. One thing that you are going to notice whenever you're working with a data frame is that we need the ability to quickly go in, find rows, find columns, etc. Like I mentioned at the outset, there's a lot of different ways that we can do this. This is a couple of very common ways that you can do it. And again, we've linked to the docs inside of our GitHub page, so you could go off and explore from there. But there's still more with data frames. And that's what we're going to take a look at in the next video.
So whenever you start working with data science and you're working with Python, at some point you're going to be needing to load some data files. The most common data file format you'll likely be working with is a CSV file or a comma-separated variable file. And one of the things we just want to touch on is what does that look like and how do I work with those files when I'm working inside a Jupyter notebook. So comma-separated variable files, or CSV files, is an extremely popular format for data files. So a lot of times when you're going off and searching for data, this will be the format it's in. And what you'll see is each row of the file contains one record, and you'll have a special character, often a comma, that's used to separate the different column values. The first row may contain actually the names of a different column, so you know what is the value in each row. So you can see here I've got the name, city, and country, and then I have the name, city, and country for a number of different airports, for example. So that might be a CSV file that I might use to analyze inside my data. Now, if you want to use this data file inside a Jupyter notebook, you're going to have to make sure the notebook can find the physical file. So how do I do it? Well, I'm going to upload the files to Jupyter itself. Now, one of the things that's a really good practice is to take that file and create a subfolder. And the most common name for the subfolder is something like data, not very original, but nice and descriptive. So we create a subfolder called data, you upload all your files into there, and then we'll be able to access it from our notebook. So we first have to create the folder, and then once we've done that, there's an upload option to upload our files. Let's move over to Jupyter Notebooks and try that out. So I have a nice CSV file here, and I want to be able to use this and access this with my Python code. But how do I get to it? So what I'm going to do is I'm going to go to Jupyter, and I'm going to create a folder so that I can keep all the data files in one place. So over here on the right-hand side, I can just say, give me a new folder instead of a new notebook. And by default, you'll see it shows up as untitled folder. So all I have to do is simply select that, and then there's a rename option to give it a better name. So I'm going to call that data. That's a fairly common name given to folders where we store data files. And then once I have the folder created, I simply select that folder, and then I can upload whatever CSV files I want to use. So I have this CSV file with information about all sorts of different airports. And I ask it to upload that file. And once it's uploaded, you can even see that you have successfully uploaded your CS file into Jupyter. So now our Python code inside the Jupyter notebook is going to be able to access this file. Once we have a CSV file with the data we want to access, there's a few things you might need to know about working with CSV files and your Python code, just aspects that can mess around with your data if you don't understand them correctly. So let's talk a bit about how to read and write CSV files and use that interacting with the pandas data frames that Christopher was talking about earlier. So the read CSV command is what we use to load a data frame from a CSV file. So let's say we have a nice file here which has name, city, country, and again that list of airports. What we can do is we can simply call read CSV, pass it the name of that file, put in our nice tidy little data folder that we created, and it creates the data frame for us. Now, something you might notice is that we did have a row which indicated the name, city, country, the names of our columns, and the read CSV automatically figured out that was the values for our column names. So you'll see the columns have headers of name, city, and country. You'll also notice that an index was created automatically because, as you saw, Christopher showed you, data frames have an index. That index was created automatically for the rows from our CSV file. Now, if you have any problems inside your CSV file, because sometimes you don't have control over where these files come from, one of the things you have to worry about in your Python code is how are you going to handle those types of errors in different situations with your Python code. So in this case, if you take a look at the CSV file, there's an extra comma in the row for London. So we have the airport's called Heathrow, city is London, and then we have this extra 2 commas. So in this case, it actually sees 4 values instead of 3 for that particular row. And by default, that's actually going to crash, and it won't load any data at all into our data frame. But good news, Pandas has some fantastic features you can use. For example, there's an error bad lines, and if you set that to false, that means just skip the rows with the errors and load everything you've got. So in this case, you can see I can load the data frame, and their row for Heathrow London is missing from the loaded data. Of course, this is only okay if it's all right to skip those rows. Now, what other situations do we deal with? Well, maybe the data file that you receive doesn't actually have values for the column headers. So in that case, it might get confused. So one of the things we can also do with pandas is your Python code, you can specify the header is none, in which case the read CSV will automatically create column headers. It'll just call the columns 0, 1, 2, and so on. So it'll create a column index to make up for the fact that it doesn't know what the column names are. So you need to know when you're writing Python code if that CSV file has a header row or not. This is one way to handle it. But you might have noticed when Christopher was writing that code to query a data frame, it was really convenient to have names for your columns. That's okay, we can fix that as well. So the other thing you can do is you can provide names for your columns by specifying the names parameter. So if we add a names parameter here, and we say I want to use name, city, and country as the names for the 3 columns, there's no column names in my file, but now you can see I successfully assigned names to each column when it created the data frame. If you have any missing values, one of the things to get used to when you're working with Python and Pandas specifically is there's this thing called NaN, and that's the way blank values are going to appear. So if we take a look at this file, you can see the record for Schiphol Airport in the Netherlands, the city value, there's nothing specified. So in this case, when I call read CSV, you'll see that it shows the NaN as the value for the city for Schiphol. If you have manipulated your data and started working with data, sometimes you want to save your changes so that you can go back to them later. So in addition to being able to read data from a CSV file into a Pandas data frame, you'll also be able to take data in a Pandas data frame and write it to a CSV file. So we do that with 2 CSV, but what you'll see that might throw you off initially is the index values will be written to the file as well. So you can actually see, because my data frame had an index, that the file created has these index values saved as well. That's fine if you want it. If you don't want it, then all you have to do is specify index equals false, in which case it will not include the index values inside the created CSV file. Okay, let's go into some notebooks and try that out in some code. So we were just talking about how we can use Python to work with data files like CSV files. Let's try it from an actual notebook. So I have here a notebook in front of me, and because I want to read the data into a Pandas data frame, because when we're working with Python, data frames are very useful for data science, I'm going to need to import that Pandas library again. You're going to get used to that line of code, I'm thinking. And let's say I have a nice CSV file containing airport information. I have the airport's name, city, and country. And you can actually see that I have that actual row is in my CSV file itself, as long with the names, cities, and country for a number of different airports. So I can simply use the read CSV command to read that data into a data frame and then display the contents of that data frame. So sure enough, you can see that the column names were read successfully from the file. You can see that index values were created, as Christopher was explaining. Panda data frames, you always have an index for each row. In this case, because there was none provided, it generated them for me. So everything looks great. But when we are writing Python code, we have to make sure that that code can handle different variations in the data file that we're loading. For example, I might have a record here where the row for Heathrow London has an extra comma in it. And that extra comma is going to mess up my code because it now thinks there's 4 values in that row instead of 3. So by default, if I just try to read that file, it's actually going to crash. And it won't put any data at all inside my data frame. Well, I have a couple of options here. I can now go digging through that file, try to figure out where is the one row that's causing the error and try to fix it. And yes, there'll be some hints in the error messages to help me find which row has the problem. But one of the neat things about data science is sometimes it's okay if we've got 1,000,000 rows, maybe we can leave 12 of them out. So maybe we just want to skip the bad rows. So in that case, we can use Python supports that as well. So what we can do is we can specify error bad lines equals false. And that simply means if you meet a row that you can't interpret, skip that row and continue. So if I run this one, you'll see it successfully loads the records, and that record from London for United Kingdom was simply skipped, so that record was not loaded. The other common situation you'll encounter when reading data files with your Python code is the file may not contain a row that tells you what the column headers are. So here I have some data, but there's no row telling me what the column name should be. By default, if you pass this in, basically Python and the pandas are going to get a little confused because they kind of assume you are passing in values. for the column headers. So it reads the first row of data and thinks those are the column headers. So suddenly I have a column header called Seattle, Tacoma and a Seattle in USA. So I need to make sure I have a way of saying, no, 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 the first row in the file is actually data. It's not headers. And that's why we have the option of specifying header equals none. So if I specify header equal none when I load the file, that's a way of saying there's no header row, and I simply want you to assign values to those column headers. And if I don't tell it what values to assign, it'll just give them a number value, column 0, column 1, column 2. Now you might, though, have appreciated when Christopher was doing some queries against the data frame that sometimes it's nice to be able to specify the columns by name. It's easier for me to remember that city contains the city rather than column index 1 is the city. So you could also, even if the header values aren't specified in the file, you can specify by using the names parameter what column names you would like to use. So if I run this, you'll see it actually successfully said, oh, you don't have a header row, so here, specify a value of name, city, and country for my 3 columns. The other scenario you're most likely to run into when working with CSV files or data files in general is a missing value. In this case, I have a data file, and for one of my records, Schiphol in the Netherlands, there's no city specified. You just see comma, comma. Now, if you read that, the way Python Pandas will display a missing value is it displays it as NaN, so not a number, if you will. So that indicates that there was no value found for that particular value inside the record. So you'll see that as well. Now, sometimes when you start really doing a lot of data science and you do a lot of cleaning of data, you'll see that when you look at data science courses. Once you finish cleaning the data, you might decide, hey, now that this data is all tidied up and cleaned, maybe I'd like to save a copy of it, so the next time I'm working with it, I don't have to do as much cleansing and rework. So one of the other neat things we can do with Pandas is we can actually write the contents back out to a CSV file as well. So if I have data in a data frame already, then I can simply say, hey, let's use toCSV, and let's write that output to a data file. Now, one of the things that's a little interesting, if I was to open that file up, and I'll show it to you in a minute, is the index values will be written in as well. So if I don't want the index values, that 0, 1, 2, 3, 4, to appear in the CSV file, then I want to specify when I write the file that I want index equals false. And that's a way of saying, please do not include the index values. So let's go take a look at the actual data files created so you can see the difference between using index equals false or not specifying index equals false. So here you can see, here's the file I created by default. You can see it added the index values from the data frame. And you can see when I did specify index equals false, that it simply added the row values itself without an index. So there you have it. You now have the ability to use your Python code to move data to and from CSV files and Pandas data frames. As you explore different data science tutorials and watch different data science videos, one of the things they're always talking about is preparing your data and the time you spend preparing your data. One of the things you'll end up doing as you prepare your data is you're going to have to either remove columns from a data frame, or you might need to take some of the columns inside a data frame and move them into a separate one, sort of splitting them off, if you will. So let's explore how you do that with the Python code as well. So in this case, maybe I have something like the actual arrival time column. If I was doing some data science and I was trying to predict how many minutes late a flight was going to be, and that's a value inside of arrival delay. Well, if I had the actual arrival time and the scheduled arrival time, well, I can just calculate arrival delay by subtracting one from the other. But I'm trying to train a model to look at all the other factors, like what airport did it leave from, and what time did it leave, and how long was the flight, and use those values to try and predict if the flight's later on time. So I don't just want to say take the actual arrival time and subtract the scheduled arrival time. Not really training a model, that's just doing a subtraction. So in this case, I might need to remove the actual arrival time column. So how do I do that with Python code? Well, there is, I'm sure you're discovering by now, Pandas has some fantastic features, and the data frame object has a drop method. So you can simply say drop a particular column. So if I say, hey, on my delays data frame, let's drop the column called actual arrival time. And then what this does, it doesn't actually modify the delays data frame. It simply returns a new data frame which contains everything except the actual arrival time. So I get a new data frame containing everything except actual arrival time. If, however, you want to make the change to the delays data frame itself, you can actually specify in place equals true, and that's a way of saying modify the data frame where I'm doing the drop. So that way I don't have to copy the values to a new data frame. I'm just saying, no, modify this one right here. And that will simply drop the actual arrival time column from delays data frame. Now, the other thing you might need to do sometimes is you might need to take some of the columns from a data frame and move them aside. One of the most common things you'll hear people talk about in data science courses is the idea of qualitative data and quantitative data. So qualitative data is descriptive data. It's things like what airport is it, and are things blue or green or gold? They're describing things. But quantitative data tends to be numbers. How big is something? How long is something? How many minutes the delay was, and so on. And you'll discover as you explore data science that those quantitative values, training models, they love that type of data. So quite often we have to take those quantitative values and pull them aside to use them to train our model. So in this case, that's my origin airport and my destination airport. So I can simply create a slice of that data frame and kick back to that module Christopher showed you where we talked about how to query a data frame. So basically, I'm going to query the data frame to return just those two columns and then take those two columns and put them in a new value. So all you do is you do a query I'm using loc here. And remember that first colon means which rows do I want back, and a single colon means return all rows. And then you specify which columns you want, in this case, origin airport and destination airport, and take those values and put them into description data frame. And that will create this nice new data frame for me with just the columns that I need. So these techniques are going to make it easier for you when you start having to prepare your data for data science. Now let's take a try doing it in code. So when you're exploring in different data science tutorials, quite often they talk all about preparing data. And one of the things I'll often talk about is either needing to remove certain columns or to move certain columns into a new data frame. So we're going to look at our Python code and see how Pandas gives us some neat tools to make it easier to do that. So we're still using Pandas data frames. So I'm going to start off by importing that library. And then I'm just going to read a data file in to give us a starting point. So I'm reading in some flight information here. And if you look at the first few rows, you can see all sorts of wonderful data, lots of different columns of information that I might be analyzing. Very typical sort of data file. Now, you might get into a situation here where if you look at this, you'll notice I want to maybe predict the arrival delay, which is how many minutes late a flight is going to be. And because this data set is so complete, it actually has the scheduled arrival time as well as the actual arrival time. Well, it doesn't take a machine learning model to figure out that if you subtract the time a plane actually arrived from when it was supposed to arrive, you can just calculate arrival delay. But if I'm going to try and train a model to predict what time future planes would be landing, it won't know the actual arrival time when I'm asking it to predict the flight that's leaving tomorrow. So I might need to delete that arrival time column. It's unnecessary. It's not going to help with my model training. So you will have situations where you want to delete it. So if I want to remove this arrival time column, fortunately, the Pandas data frame has a feature to help me with that. There is a feature called a method called drop. You tell it which column you want to remove, and you can then say, create me a new data frame without that extra column. So if I do that, this new data frame I create, you'll notice it still has the scheduled arrival time, but the arrival time column is gone. Now, one of the things you may notice here, and this is something to keep in mind when working with Pandas data frames, is it didn't actually modify delays data frame. It simply created a new data frame without that extra column. If you want to modify the delays data frame itself, you can do that. Pandas will support it. You specify the value in place equals true. And that means modify the delays data frame itself. So now the delays data frame has no longer got that arrival time column. So it's up to you, depending on how you like to work with your code and what you're doing with it, whether you wanted a new one or to modify the existing one. Now sometimes we have to split up different columns. One of the things that comes up a lot said in data science is this need to sometimes only have the numeric values to do our analysis or only to look at the string values, because you'll discover as you explore data science that there are different techniques for handling string values versus numeric values. So it's not unusual to take your data frame and say, hey, take the values that are more string or qualitative, put them in one place. Take the quantitative or numeric values, put them in a different place. So in this case, if we take a look, maybe I want to take all the string type values, what we would call qualitative data, and move that into a separate data frame. Well, to do that, you simply use a data frame query, similar to what Christopher was showing you when we showed you how to do querying a data frame. So we say, let's do a query using loc of our data frame. And we say, which rows do we want? Colon means return all rows. Which columns we want? We simply list the columns we want returned. And then we take that query result and we put it into a new data frame. And presto, we now have our brand new data frame containing just the columns we needed. So there you have it. Python, with the powers of pandas and data frames, gives us lots of clever, simple ways to remove a single column or to move aside or split a data frame into a new data frame. So continuing with the fact that in a lot of data science courses and tutorials you look at, there's a lot of talk about preparing data. One of the other scenarios that you'll often have to handle is handling duplicate rows. You'll see that data science really doesn't like it when there's multiple copies of the same row, and they also tend to get upset or crash, even can crash code if you encounter rows which have missing values. So let's see how Python and the pandas data frame gives us some methods and techniques for handling those situations. So specifically, let's start with the missing values. There are many different data science methods you'll use which will actually crash if they hit a row with missing values. So if I had the data frame here in front of me for some airport information, because I have an arrival time and a delay time that are missing values showing up as at NAN, this could actually cause my code to crash. I won't be able to train a model. So one of the things we need is a way of just knowing if a particular data frame has missing values. And the info method of the data frame is fantastic for this. What it'll do is it'll tell you all sorts of great information. One of the things it'll tell you is how many rows are in your data frame. And then for each of the columns, it will tell you how many of the rows in that data frame contain values that are not null. So you can see here that the flight date, well, all 300,000 rows contain non-null values. So there are actual values in every single row for the value of flight date and for a unique carrier. But wait, when I hit tail number, out of that 300,000 rows, only 299,000 or so of them have actual values, non-null values in them. That means that some of those rows do contain a null or a missing value. So you can see here there's actually 3 different columns that have a number lower than 300,000 with non-null. So that indicates to me there are some missing values for some of the rows of these 3 columns. So now that I know I have some missing values, how can I now use Python to deal with those values? Well, fortunately, Python Pandas is designed for this, so it has a drop NA method, which means drop NA, those NaN values, and it allows me to remove those rows from my data frame. Now, one thing to be aware of, very specific when working with Pandas data frames, when I do a drop NA, I am not actually dropping the rows from the data frame itself. I am saying drop the rows and then copy the data frame with the dropped rows to a new data frame. So here I have this one row with null values. So what it does is it creates a new data frame called delay no nulls data frame, and it's missing that row 2 which had the null values or the missing values. If, however, you want to actually modify the data frame itself, you can do that by just specifying in place equals true, and then what happens is it literally just removes that row from the existing delays df data frame. The other scenario we might need to handle is duplicate rows. So you will often find that a lot of times when we're working with data science, you'll be given files from multiple different places, and then you combine all those files together into one data frame. And that may mean that you get into situations where sometimes rows may be loaded multiple times. So we also want to handle those duplicate rows because that can skew results when you're doing data science. So here I have some data in front of me and some simple information about airports, but I have 2 rows for the airport in Dulles, Washington. So how do I handle that using my Python and my Danda and Python and Pandas? We have the airport's data frame we call duplicated, and what that will do is it will return true or false for every row. And if a row that it locates is a duplicate of a previous row, then we'll see a true. So you can see here that the first row it returns false, second row is false, because up until now it has not seen a duplicate of Dulles. The next row is another row. It's exactly the same. So now it says true because this row is a duplicate of a previously seen row, and the remaining rows are all false. I also want to make sure we highlight here that it is the entire row that's a duplicate. We have multiple records with a country of USA, but duplicate is looking for records with the entire row is a duplicate. So this allows us to locate duplicate records. Now, how do we get rid of them? Well, there's a wonderful little method called drop duplicates. And I'm going to use that same little trick I did for dropping missing rows of missing values. I'm going to use the in-place equals true to say within this data frame itself, drop the duplicate rows. And what that's going to simply do for me is get rid of that second row for Dulles, Washington. So my data is all set, nice and tidy, ready for me to go on and play with my data science. So now we've dropped our duplicate rows. We're ready to start going and doing things like training models. Now let's try all of this out in actual code. So as we're preparing our data to train models, we do have to make sure that the data we're working with doesn't have missing values, which can cause issues, and actually when you try to train a model might give you an error. And we also need to deal with duplicate rows because duplicate rows can skew the result when you're training data models. So now let's take a look at inside our actual code using Python and Pandas data frame methods, how we can handle missing values and duplicates. So taking a look here, we're still working with Pandas data frames, so I'm going to import that wonderful Pandas library. And I'm going to start by loading a nice data set here into our data frame, which contains all sorts of information about different flights that have come and left and arrival delay information. Now this is a very big data frame, and I do not want to go reading through every single row to find out which rows might have a duplicate value. But fortunately, I can use the data frames info method, and what that will do is it will tell me all sorts of great information about that data frame and of the data inside it. So it tells me things like, hey, you have 300,000 rows inside that data frame across 16 different columns. And it also tells me how many, for each column, how many rows contain actual values, non-null values. So I can see that flight date has 300,000 rows, all containing non-null values. Unique carrier, all the rows contain non-null values. But when you get to tail number, you'll notice only about 299,000 of the rows contain non-nulls. Or for arrival time, but again, there's a number of records here. Most of the rows have a non-null value, but that must mean that some of them do have a null value. So this is a simple way to check and see if you have any rows which contain a null value or any particular columns that contain null values inside your data frame. So now that I've identified I do have rows with missing values, nulls, NaNs, these words can be used interchangeably here, how do I handle that? So if we go back to our code, once you've identified it, you can use the drop NA, and what that will do is it will drop the rows with missing values. Now, by default, this does not modify the delays data frame itself. Instead, what I'm doing is I'm saying drop missing rows with missing values, and take those rows, the remaining rows, and put them into a new data frame. So if I run this, and then I do an info on the new data frame, you'll see it only has 295,000 rows left, because all the rows with missing values have been removed, but you can see that every single column, all of the rows contain actual values. So I can confirm that I have successfully dropped every missing value or every row with a missing value from my data frame. If, however, you prefer not to create a new data frame, if you just want to drop the missing rows from the existing data frame, delays.df, you can do that too. That's supported. There's a function called, or a parameter called inPlace equals true. When you set it to true, basically that's saying modify the delays data frame itself. So now what I've done is I've actually dropped the missing rows from the delays data frame. So you can see once again, now it only has 295,000 rows, but every single one of the columns, all the values in there have no missing values, no nulls. The other scenario we sometimes have to deal with is duplicate values. So one of the things you'll find is sometimes when you're doing data science that data may come in from multiple files and then all be merged together into one data frame. So as a result, you can end up with some duplicate rows. And that can skew results when you start doing data science. So one of the things we need to do is check if there's duplicates and then deal with them. So I'm just going to import a very small file here so that you can see it has duplicate values. So it has 3 records from USA. Those aren't duplicates. They just happen to be in the same country. But here, I can see that there's actually 2 records from Dulles, Washington. Now, I've deliberately displayed a very small data frame here so you can see that. But what if the data frame was too big to just show on the screen? How could I quickly just check and say, hey, look at all the rows and tell me if it's duplicates? Well, the pandas data frame has this duplicated method. And what that will do is it'll return a true or false, indicating whether or not a row is a duplicate of a previous row. So in this case, the 3rd row, this one here, 2, Dulles, Washington, is a duplicate of the previous row. So you can see that the one with the index of 2, it says, yes, that row is in fact a duplicate. It does have to be the entire row if it's a duplicate. Simply having the same value in a column does not make it a duplicate row. Once you've identified you do have duplicates, if you want to get rid of those, all you need to do is call drop duplicates. I'm using that same parameter, in place equal true, to say drop the duplicate rows inside the airport's data frame itself. So now when I run, you can actually see I've successfully gotten rid of that extra Dulles, Washington record. You will notice, of course, that index number that can cause gaps in your indexes. So just be aware of that as well when you're duplicating or dropping duplicate rows. So there we have it. We can figure out if we have any missing values in our data frame, get rid of the rows that do have missing values. We can determine if we do have any duplicate rows, and we can get rid of those duplicate rows. So now you've got your data a little more cleaned up and ready for data science and training models.
We've seen a lot of different ways that we can manipulate data. Now, one of the biggest tasks that we're going to have is to get some insights from that data, that we're going to want to be able to try and predict certain behaviors, try and predict certain values. Now, in order to do that, what we'll need is to split up our data that we'll need to be able to say, hey, these are all of the things that are going to impact some particular value. Or to put this another way, to give you a couple of different examples or scenarios that given X data, predict Y value. So for example, given a particular customer, I want to be able to predict whether or not they're going to buy a product. Or given a shopping cart, I want to be able to offer up some other items that that customer might be interested in. If you've ever shopped online, you've seen this behavior where you've seen that little spot that says other customers have bought. This is exactly what's happening behind the scenes, is it's a little bit of machine learning. And along those lines, with our data, since we've been looking at flight data, that what we want to be able to do is say, given a particular flight, predict the time that it's going to be delayed, whether or not it's going to be early, etc. But in order to do that, what we're going to need to do is to take our data and split it up. That we're going to need to create 2 different data frames. That we're going to want to set up the labeled data frame, basically what we want to predict. In our case, that's going to be how late or how early is a particular flight going to be, into a data frame commonly labeled as Y, and in particular, a lowercase y. I know I've said previously my challenges with single letter variable names and things like that. This is convention, so I do follow along with it, even though it pains me inside. But yeah, so the value that we're going to predict is going to be in Y. So in our case, the value that we want to predict is the minutes early or minutes late that it's going to wind up being, that particular flight would wind up being. The data that's going to influence this, and this is going to include things like the time of departure, the time of arrival, the airport that it took off from, the airport that it was going to, etc. All of that information is going to make up the features or what's going to influence the label. So if you stop and think about it, the airport that we're coming from, the airport that we're going to, when you're talking about things like weather, air traffic control, etc., all of those different things are going to have an impact on whether or not a flight is early or a flight is late. So we're going to take all of that information, put that off somewhere else into a different data frame. This data frame is going to be labeled as capital X. So if we want to take a look at a little bit more of a concrete example here, what we're going to notice is we've got the distances, we've got the elapsed time, and then we've got the arrival delay. So 7 minutes, 4 minutes early, 5 minutes, etc., the whole way down. What we want to be able to predict, or our label, is going to be that delay, and everything else is going to influence it. So if we remember from what we had before, using that location indexer, we're able to go get all of the rows for that arrival delay column, and then in turn, we can go grab all of the features by just grabbing everything else. And we can either list them off like we have here, or maybe if it was basically everything but that last column, we could have gone ahead and set up a range where we indicated, hey, go 0 to whatever it might be. The end result is going to wind up being that we'll have two different data frames, X and Y, where X is going to be all of our features, and Y is going to be the label that we're going to be trying to predict. You're also going to notice that the index is going to come along for the ride. That gives us the ability, and also gives our trainer the ability to align everything properly, so that way we know which pieces of data are going to be correlated to which eventual results here. Now, the other thing that we're typically going to have to do is to split up our data into training data and testing data. When we think about trying to train up a machine learning model, or really kind of train anything up, what we're going to need to do is feed it some information. Hey, this is what's going on. We're going to make some assumptions based on that information, and then we're going to want to be able to test our assumptions. Like this is kind of how we learn. That we'll learn something, and then we'll go off and we'll test that behavior, and we'll see, hey, is this in fact the case? Is this not the case? That's exactly what we're going to do when we're setting up our machine learning model. That we're going to say, hey, this is the information that I want you to use to train yourself, and then this is the information that I want you to use to confirm that all of those assumptions that you've now generated are in fact correct. Typically, you're only going to have one set of data. So what you'll do is take that one set of data, take some of the rows, turn that into the training data, and then some of the rows, and turn that into the testing data. So you're going to notice that we've got our data frame X. What we're going to do is we're going to split that up into some training data and into some testing data. I want you to notice the indexes here. And you're going to notice that on the training side, we're going to have 0 and 2, whereas on the test side, we're going to have 1 and 17. Everything else that's there is sort of irrelevant. The takeaway that I want you to get out of this is we didn't just simply say, all right, well, the top 70%, that's what we're going to use to train, and then the bottom 30% is what we're going to use to validate all of those assumptions that we're going to use to test. Because that's not really going to give us good results, because information could be skewed. It's possible, depending on our data set, where it is that we've loaded it in from, that maybe there was a sort that took place. So maybe, for example, everything is sorted based on the destination airport. So now what I'm going to wind up with down at the very bottom is everything that's landing in, I'm trying to think of an airport code that starts with like a Z. So whatever that might be, I'm just going to use SEA, SeaTac, just because S is sort of a later letter. So let's say that I've got Seattle down at the very bottom. So now that winds up becoming my testing data. So all of the assumptions are going to be based on everything but Seattle, and then I'm going to wind up testing those assumptions against Seattle. And you could easily see, hey, that's not really a good way to do things. So instead what we want to do is we want to randomize this. So that way we're not going to be biasing our training and our testing. So when we go in and we look at our results, we look at our accuracy, we're going to know, oh, okay, we've done a good job here. We're testing this and training this on some nice random values. That's exactly what's happening here. So as a general rule, train on 70% of your data and test on 30% of your data. Somewhere in that ballpark. It's a general nice starting point. It's a nice general rule of thumb that you can follow. Now, there's a nice little library that's available to us called Scikit-learn that does an awful lot of really nice things in this space. One of the things that it does is it offers us a train test split. And what's great about this is we can actually just give it our X data frame and our Y data frame, so our features and our label, and then it will give us back everything that we might want. So we pull that little function in, then we go ahead and call it, and what you're going to notice is that it will give us back that xtrain, xtest, ytrain, ytest, where xtrain is going to be all the features we're going to train on, xtest is what we're going to use to test all of those assumptions that are generated. And then the ytrain and ytest is going to do the exact same thing except for the values that we want to be able to predict. Again, that's going to be that label. X and Y is what we're coming in with. The test size is where we're going to indicate how we're going to split everything up. Now the last item that's on there is the random state. Now, we're setting the random state to a value here, and by doing that, we're now seeding how random values are going to be generated. So at the end of the day, when you specify a random state, you're actually not going to be getting random values anymore because it's always going to be basing it on that exact same seed. The reason that you might decide to do this is if you're looking for some level of replayability. So that maybe what I want to be able to do is to test out different algorithms or otherwise, and I want to make sure that we're always doing it on the exact same training data and on the exact same testing data. So that's why you might decide to set that random state. The end result of all of this is we're going to start with a data frame that looks a little bit like this, where what we want to be able to do is to predict our delay. So we're going to split off our distance and our elapsed time into the X side. We're going to set up the Y side as the predicted delay. And then you'll also notice that we're going to have our train section and we're going to have our test section. And we'll be able to use those to in turn train up our model. Let's go in and see a couple of code examples so we can hopefully bring all of this together. Let's take a look at a code example of how we can split up our data into training data and testing data. So just like before, we're going to need pandas, so let me import that in. And let's import in a CSV file and check out its shape. And what you're going to notice is the fact that we have 30,000 rows and 16 columns inside of our data. Now, we're going to keep things a little bit simple here. That normally at this point, after you've loaded up your CSV file, you would probably do some exploration, start to get rid of some bad data, maybe bring data in from somewhere else, etc. We're kind of going the green path here where everything's just going to work for us. So we're making our lives a little bit easier, admittedly, but in the real world, there'd still be a little bit of work that that you would have to do here. So 30,000 rows, 16 columns. Let's go ahead and start to break down all of that information into the appropriate spots. So we're going to use the distance and the elapsed time here. Boom. And so you'll notice that we called head just so we could see the first 5 rows here. All of that looks nice. And we're going to grab the delay, and that all looks good. So right now, what we have is we've got two new data frames. We've got X, which is our features. This is everything that we're going to use to try and do our predictions. And then over on the Y side, this is the value that we're now trying to predict. So given the distance and the amount of time that it took, how late is that? That's what we're trying to set up here. Now, what we need to do in order to be able to feed this into a model and start to train that up is we need some testing data and some training data, where again the testing data is going to be used to validate all of the assumptions. The training data is going to be used to build up that model. We're going to use that nice little helper function here of train test split, and then we're going to set up our xtrain and xtest, ytrain and ytest, and we're going to pass in the x and y. Again, our x is going to be our features, our y is going to be what it is that we're trying to predict. We're going to set up 30% as the test size, and then the random state of 42. And so now, when I run this, and I take a look at the shape for that xtrain, what we're going to notice is 21,000 rows inside of there. And when we look at the test, what we're going to notice is 9,000 rows inside of there. So you'll notice that we now have 30% of our data that's going to be set up as testing, and we're going to have 70% of our data that's set up as training. Now, if you're anything like me, and I know I am, you might be looking at that real quick and going, hey, wait a minute, those numbers don't seem to line up. You have 30,000 rows. Shouldn't it be 20 and 10? Remember, we didn't say a third. We said 30%. So 30% of 30,000 is 9,000. Maybe it was just me that got caught on that. Maybe you're looking at that and going, oh, okay, yeah, that makes complete sense. Either way, there you are. So those are our couple of numbers. And then what we'll also notice, if I go in and grab the head of train, for example, that I did in fact get back completely random rows on the train side. And then if I took a look at Y, I'm going to see the exact same thing. So there's our train and test, again, the shape on both of those. And then what you're going to notice is on the head that, again, we're getting our random IDs. But I do want to point out this simple this fact here, that you'll notice if I do this, I can actually go x train head, boom, boom. There we go. Let's go ahead and run this. And I'm going to just draw on the screen, make it a little easier. Whoops, let me zoom it real quick. There we go. So up at the very top there, this is my Y. And then down below, that's our X. And what I want you to notice here is that the IDs line up. And that's important. So then that way, because we've split all of our data up, I've got my features over here, I've got my labels over here. Again, what's going to drive the prediction, what it is that we're trying to predict. I've now got that in two separate data frames. We need to be able to, at some point, bring all of those together. That's what that ID column is going to do for us, and that's why all of that matches up. Okay. Now that we've got the data ready to go, let's see how we could begin to train up a model. Before we get into this module, I want to make sure that I'm setting expectations appropriately. We are not going to get into selecting which model, differences between them all, etc. There's a lot to that. And we actually do have content that you can go check out that will give you more information about that. I've mentioned a handful of times already the GitHub repository. Again, if you go there, you're going to notice that we have links to additional resources where you can start to dig deeper into those types of conversations, like, hey, what's the difference between logical regression and linear regression? So you can go check all of that out. The example that I want to walk through here is going to use linear regression, which is designed to predict a value and potentially show all of us that on a neat little chart. That's what linear regression is all about. And again, what we want to be able to do is to predict how late or how early a particular flight is going to be. That's exactly what linear regression can do for us. Again, if you want a deeper conversation on all of that, you can check out the links inside the repository and learn more about all the possibilities there. Let's go ahead and take a look at how we're going to take all of our prepared data and start to feed that into a model. So if you remember from before, this is what we've got. We've got our training data, we've got our testing data, we've got our features, we've got our labels. We're ready to go. We're all dressed up. Now we just need a destination. We need to have somewhere to go. And that somewhere that we're going to go is going to be into some form of a model, into some form of an algorithm. And in this particular case, it's going to be linear regression. So linear regression is going to give us that ability to predict a value there that's going to be on some form of a line, thus the name, linear regression. See, it's not just a clever name. Now, there's a little fit function or a little fit method that we're going to use after we give it all of our data that's going to actually give us the ability in turn to start to predict values and give us outcomes for any new data that we fill into it. As I mentioned at the outset, there's a lot of different ways that we can do this. There's a lot of different classes that are available to us, and we can use Scikit-learn, and there's other utilities out there that you might want to check out. We're going to use Scikit-learn to perform this operation. So it typically is going to follow kind of the same pattern here, where we're going to import in the desired class that's going to do our work. We're going to create an instance of that, and then we're going to call fit to have it start doing all of its work. Now, that's what I'm about to demo here. But as you might expect, there's still more to it. So when I go in and I run all of this, the next question becomes, well, how accurate is that? And that's what we're going to see in a later module. For right now, what I want to focus in on is the mechanic. How do we now take our data and fit that into a model? That's going to be our code demo. Let's see how we can set up our model. So what we're going to do, as previously mentioned, is we're going to bring in our pandas library and bring up our train test split. And we're going to do exactly what we did before. So I'm not going to spend a lot of time walking back through this code, but this is what we've seen, that we've seen how to read into CSV. We've seen how to drop our values that are null or otherwise. We're going to then go grab our distance and elapsed time. We're going to grab our arrival delay, and we're going to split all of that up. So basically, everything that we've seen, all of those individual demos, all right there. It all comes together. So let's go ahead and run that little bit. Boom. And now we're ready to set up our model. Now here's what I want you to notice. We're going to go grab our linear regression from Scikit-learn. We're then going to set up an instance of that class, and then we're going to go ahead and call fit. We're going to pass in our training data and for our features and for our labels. So again, X is going to be what's going to drive the value. Y is going to be the value that we're going to drive. Now, I'm openly going to admit here that the ending is a little bit anticlimactic because we've now set up this model. But we don't know anything about it. We haven't seen yet maybe how we could predict a value. And you'll also notice that we haven't yet used any of that testing data. Well, the reason that we haven't used any of the testing data is all that we've done at this point is we've just done our training. All that we've done is we've set up our model. Now it's time to turn our attention to see how well did we do? And that's what we're going to look at in the next module.
So Christopher just walked you through how to actually train a model. And yes, that can feel a bit anticlimactic. I once was chatting with a data scientist who told me that 80% of your time is spent actually preparing the data to do the training, and only 20% of your time is actually spent training the model. When it gets down to the code, it's really one line of code that you execute to train your model. You spend most of your time doing that preparation, getting the data ready for training. And it's interesting, you may notice over the next couple of modules, same sort of thing. Really, it's just sort of one line of code does all the magic for us. It's getting the data ready that's going to take you most of your time. But we have got a model trained based on the code that you saw with Christopher. So now let's take a look at how we actually test the model once we trained it, so we know it's actually somewhat accurate and that we can rely on that model and make decisions based on that model. So how do we test a model? When we were looking at Christopher's content, you saw that we had split up our data into 4 parts. We had xtrain and xtest, which was the xtrain is the data we use to train our model, along with ytrain. Ytrain being the values we're predicting, xtrain being our features. And then we also had test data, xtest and ytest. And that was data we had put aside for testing. And that's what we're going to use to check how accurate our model is. So what we can do is take that xtest data we put aside, and we're going to use that to test our model. So we use predict is the method that we typically use on the different models to say, here are some values that we would like to test with. Please try and predict values for those different values in our test data. So we take the data in xtest, and we pass that in using our regressor, which is the model object we had created, and we call predict, and we pass in the test data, and it will pass back a prediction for each of the rows of test data. And we can put that into a data frame. I'm calling it y predicted, because that's sort of nice and consistent. We have y test for the actual values for our test data, and now we have y prediction containing the predicted values for our test data. So now, once we've finished that, we'll be able to compare the results we have in y-test, which is the actual values that happen for each record, to the predicted values our model gave us for each of the rows of our test data. And by comparing, here we, the first row, the first flight was 5 minutes early. Our model predicted it would be just over 3 minutes late. The second row, it predicted it would be 20 minutes late. Our model predicted it would be about 6 minutes late, and so on. So now we get a sense of whether our model's doing a good job making those predictions. Now let's take a look at this in some actual code. So when you wrapped up with Christopher, you had successfully loaded some data, split it into training and test data, and even trained a model. And so now the next step was basically to see if the model could make predictions, and if so, how accurate are those predictions, so you know if you can trust the results coming from your trained model, and if it's going to make sense to make business decisions or to make changes based on the predictions. Can you trust the predictions from your model? So we need to be able to test our model and get a sense of how accurate the predictions are. So what we're going to need first, though, is to rerun some of our code we saw earlier. So I'm just going to import all the same libraries you were using in the code with Christopher when you were training your model, and I'm just going to rerun the same code that you were looking at that was going ahead and said loading our data set, still working with the flight data set, getting rid of the rows with null values, splitting up our features and our labels, the values we're using to train the model and the value we're trying to predict, and then splitting that into training and test data. So that's all code you'd seen before, and you finished with that one little line of code. You know, it's crazy. You put all this work and think data science is going to be so complicated to train a model, and you discover training a model is all of one line of code. It's preparing the data that really takes up most of your time. Now that we have trained the model by calling fit, we have a trained model, we call the predict method to actually make a predictions. And now if we're going to predict values, we need to be able to predict values. If we want to check accuracy, we'd like to make some predictions for values where we actually know what the actual outputs were. That's why we put aside that test data, because we have a whole bunch of rows inside xtest for which we actually know what happened. We know how many minutes late those flights were. That's the values we stored in ytest. So if we pass the values in xtest, which are all a bunch of flights where we know what happened, and we say to the model, hey, predict what the flight delay will be for each of these records, then we can compare the predicted values to the actual values. So that's exactly what we're going to do. So if we look at our code, though, it's really only one line. We're going to call regressor, which if you remember up here, that was what we called our linear regression object, which we just trained. Now we can ask that trained model to predict values for each row in xtest, and we're going to put those in a data frame called yPredict. So we're going to put that into yPredict, and now it's done, and you can print those values out, and you can see all the different values it's predicted for each row. And then you can compare those values to the actual values we had put aside for each of those toast rows when we did our splitting of our data. And you can see that for the first row, the actual delay, it was 5 minutes early, that first flight, whereas our model predicted it would be about 3 minutes late. The second row, the actual flight was 12 minutes early, and our model predicted it was going to be about 6 minutes late. Third row, it predicted it would be 4 minutes late when the actual value was about 9 minutes early. So I can see that my model's maybe not quite perfect yet, and this is where you need to go look into those data science courses, and you would learn techniques to go back and see how you get better accuracy on your model. But we're focusing on the code part here, and you can see here we have that ability to take our test data, pass it to the model, and get back predicted values. What I'll take a look at in the next module is some mathematical calculations you can do to get a better sense of accuracy, because reading through all those rows manually could be a little clunky. So we've seen how after we've trained a model, we can compare our test and our predicted data. But the first time we did it, when we looked at it, we just saw a list of values. And it's not really practical to visually look at all the results from our actual test data results, the actual values predicted, versus the values predicted by our model, and compare them row by row by row visually. It's just not a practical way to look at things. So what we'll typically do is we take advantage of the fact that we're programmers, and we use some code to do calculations to get a sense of the overall accuracy of how effective our model is at making predictions. But it still comes down to comparing the predicted values and the actual values. But the difference is what we want to do is use some calculations to compare the two. One of the most common methods we'll use is something called mean squared error. So the mean squared error, if you actually look at the formula for it, is just the mean of the actual values minus the predicted values squared. Now, I could write some Python code. In fact, you learned enough in the Introduction to Python course to write a loop that would go through all the actual values, go through all the predicted values, subtract one from the other, calculate the value squared, and perform this calculation. You could do that. But there's a better way. Luckily, there's a whole bunch of great libraries out there that will help you when you're doing data science. The Scikit-learn library has all sorts of great functions for scientific calculations, including one called mean squared error. So all I really have to do is import the Scikit-learn library. In particular, when you're doing these types of calculations, you'll probably want the metrics. And then I just say calculate the mean squared error of my actual results versus my predictive results. And now I can get a sense of my total accuracy of the model. And generally speaking, just from a data science perspective, a lower value is going to be better. Lower error is good. Now, sometimes there's a whole bunch of different numbers and metrics you can look at. Another one is the root mean of squared error, which is just the square root of mean squared error, which we just calculated. But Scikit-learn doesn't have a method we can use to calculate it. So there's another library you're going to start exploring with and playing with when you do data science as well, which is Numpy. So what Numpy will do is Numpy has all sorts of functions designed for straight math calculations, and including one which calculates a square root. So if I have the mean squared error method in Scikit-learn, and I have the ability to calculate a square root with Numpy, then I can put those together to get my root mean squared error. So these are the two libraries that are really going to help you when you're looking to evaluate the accuracy of your model. Different types of models you're going to learn as you explore data science are going to have different metrics that you evaluate to check the accuracy. But generally speaking, between Numpy and Scikit-learn, you should always have some method out there that's going to help you perform those calculations. So Numpy for the basic mathematical calculations, and Scikit-learn often has a lot of specific methods for predicting and measuring accuracy of your models. So now let's go take a look at that in some actual code. So we've trained our model and we've tested our model. We've passed in the data in xtest to predict a set of values, which is now stored in yPredict, and then we've compared those values to what we had in yTest, which were the actual values for our test data. But so far we were just comparing those row by row, and that's very hard when you're trying to get a sense of the overall accuracy of your model. So what we want to be able to do is do some calculations to return to us a sense of overall accuracy of the model. So if we take a look at the code here, I'm importing a new library called Scikit-learn, which we're going to be using here. So we're going to start by just training and testing our model again. This is the exact same code we've done in the previous lessons, so don't worry about that code. You'll see it's exactly the same code you remember before, still doing linear regression, training our model, and then passing in some test data to get some predicted results. So what we're going to do differently now is we're going to use some calculations to determine the accuracy. One of the many different ways to measure accuracy is to look at the mean squared error, and this is calculated by doing the mean of actuals minus predicted values squared. And you could write a loop that would do that using straight Python code. You've learned how to do that with learning how to do loop logic when you're in the Introduction to Programming courses with the Python. But if you actually go to the Scikit-learn library, you'll discover it contains a number of different methods to help you calculate metrics, which are great for evaluating your model. Most of them are designed for this. So what I can simply do is I can say, hey, let's import from Scikit-learn the metrics and just calculate mean squared error, pass it the actual results for your test data, the predicted results for your test data, and it returns the mean squared error. Just as a general guideline, for this particular metric, a lower value is good. Another common metric you might measure is the root mean squared error, which is literally the square root of mean squared error. But Scikit-learn doesn't have a method for this. That's okay though, because there's another library we can use called Numpy. And Numpy has a number of different functions you can use for mathematical calculations, including one which calculates square root. So if we just calculate the square root of the mean squared error, then we get root mean squared error. So Numpy is another useful library that we use when we're trying to get these calculations to measure our averages and our totals to get a sense of overall accuracy. I'll just throw out a couple of other examples here. Different types of models are going to have different metrics that we look at to measure accuracy. So when you look at data science courses, depending on the type of model you're learning, you're going to see different metrics. But the key here being Scikit-learn and Numpy will often have the methods to help you do it. So just a couple of other examples here. We've got the mean absolute error, and it's the mean of the absolute value of the actuals minus the predicted values. And the difference being it's a little less sensitive if you have some odd data in the middle of it, what we call outliers. Again, lower numbers are better. And another common one is the R squared. And in this one, generally speaking, the higher your R squared, the better of a model. So I'm not going to get into what all these numbers mean and represent, but the key takeaway here is when you're a training model, to measure the accuracy, different models will have different metrics. Scikit-learn and Numpy are going to help you out a lot. So in the last model, when we were doing calculations, we explored very briefly a library called Numpy. Now Numpy, if you've actually started exploring any data science courses already, you may have actually already encountered Numpy. You'll see a lot of modules talking about using the Numpy objects and things like that, because Numpy is actually a library that's used not just for calculations in general, but it's also designed for doing like matrix calculations. So because it can do matrix calculations, it needs a way of storing matrices, so it has an ability to store things like arrays and such as well. Now, why am I saying all this? Well, because it turns out if we take a closer look at the values that we predicted when we trained or when we tested specifically our model, you might notice something interesting. So when we called predict for our model and passed in the test data and asked it to create some predictive values, if you actually look at the type of Y prediction, you might have noticed something, which is that Y prediction, if you look at the data type, is actually a NumPy array. So it's not actually a data frame, whereas Y test is a data frame. Now, this is significant because so far, we've been working with pandas data frames. So when we were doing queries, we learned how to query a pandas data frame. When we were looking at information, like how do I display the first few rows or the last 10 rows and so on. We were doing all these with methods on pandas data frames. So it's even possible, maybe when you were trying some of this out yourself, that you did something like, hey, let's do a ypred.tail to look at the last 5 rows, and it failed because that method doesn't exist on NumPy arrays. That's a method that only exists on a data frame. So the other thing that might happen is you might be doing things like trying to merge 2 data frames together or split 2 data frames apart, and you try and do, again, those actions on this ypred, and it'll all fail because, again, it's not a data frame, it's a NumPy array. So let's just talk a little bit more about NumPy and explore that some more. So it's a Python package for scientific computing used for a lot of matrix calculations. It has an assortment of classes and methods that'll help you out. And when you're doing Python for data science, you'll end up working with a mix of pandas objects and methods as well as NumPy objects and methods. In NumPy, you have an array. So in pandas, we had a series. That's very similar to a one-dimensional NumPy array. In fact, if I want to declare it, if you compare the code for a NumPy array on the left and a pandas series on the other side, you'll see the code is almost identical. Here, I can tell it's an array because I declared it as a NumPy array. Here, I declared it as a pandas series, but the syntax is the same. And if I want to print all the values in the series or a specific value in the series, the syntax is, again, still the same. The big difference is you have an implicit index with NumPy arrays, and you have an explicit index that's displayed 0, 1, 2 when you have a pandas series. And they have different functionality. A two-dimensional NumPy array is very similar to a pandas data frame in terms of its structure. And when you're writing the code to access it and to create it, again, it's going to look very similar. I declare a NumPy array, and I specify the values for each row and each column. And if I want to print all the values, I just pass in the array name. If I want a particular row or a particular value, I specify the index column position and the index row position. Row, then column, just in that order. And then if I'm using a data frame, again, pass in the values for the different columns and the different rows, print the entire data frame, or you can use that iloc, index location, to specify a row and column position to request a specific value. So again, at first glance, they seem to be almost identical. But they are different classes and they have different capabilities. So one of the things you're going to run into is there's going to be times where you may want the functionality of a data frame, but it's in a NumPy array, or maybe you want the functionality of a NumPy array and it's in a data frame. Or you're trying to merge data from 2 objects together. One's NumPy, one's pandas data, one's a NumPy array, one's a data frame, and when you try to merge them, you'll get errors saying they're different data types. So you might need to move data between a NumPy and a pandas object. I'll give you one example here. In this case, if I wanted my predicted values to be in a pandas data frame instead of a NumPy array, all I have to do is call the data frame constructor, pass in the NumPy array, that's an object it will accept, and it will return to me a data frame containing the same values. Now you can see that ypred is still a NumPy array, but my ypred data frame is actually a data frame. So as you explore that world of data science, be prepared. This is going to happen to you. You will have times when something's in a NumPy object and you need it in a pandas object, or something's in a pandas object and you need it in a NumPy object. I'm not going to cover every possible conversion that might exist, but be prepared for it, and there's lots of great documentation out to help you when you're looking at a specific scenario. Now let's take a look at this in the actual code. Okay, so let's pop into our code and see what we've already got done. We have imported our pandas library and the model we want to use to train our data. We have gone through, read our data. We have gone through, split it into training and test data. We have trained our model, and we've even tested our model by passing in a set of test data. Now, when we were done this, you might have actually noticed when we were comparing the results of our predicted and actual values, that when you actually display the values that were predicted by the model and compare that to the values that were in the actual values for the test data, but they displayed differently. And I'm guessing some of you out there were like, I wonder why those are showing up differently. There is a reason for it, because these 2 objects are not actually the same type. If you take a closer look, and we can use the type method to ask for the data type of an object, very useful anytime you're not sure what you're working with. If you look at the type of yPredict, it says it's a NumPy array, whereas yTest is a Pandas data frame. Now, up until now, we've been very focused on working with Pandas data frames. So what is this NumPy array thing? It's very similar to a data frame, and it's got a lot of similarities, but its functionality is not the same. They are actually different classes. So what does this mean in terms of our code? Well, it means if we try and do something like call the head function to display the first few rows of the array, well, that's actually going to fail because NumPy arrays do not support that method. That's a data frame method. So it's not available on the NumPy array class. So let's just take a little closer look at these. So the NumPy library in general, just so you know, it's basically a library that's designed for mathematical calculations and matrix calculations. So since it does matrix calculations, it has to support arrays. And a one-dimensional NumPy array is very similar to creating a series in Panda. So if you look at the code, it's very similar to create an array versus series, but really only the big difference is I'm using a different constructor, the array constructor versus the Pandas series constructor. But aside from that, all the syntax is the same, except that they do have slightly different functionality. If you want a two-dimensional array, which we do with the data frame in Pandas, you can create a two-dimensional array using a NumPy array. And you'll see it come back. And again, very similar to what we have with a Pandas data frame. The biggest difference between the two really is when you're working with Pandas, the index is explicit. You see the index numbers displayed. Each row does have an implicit index when you're working with NumPy arrays, but it's not displayed when you're printing out the values. But you can still use it to reference a particular row. For example, up here, when I was querying my series, I said, give me the value that's with row index number 2, which is Narita. Well, you can see in the Pandas series that row index number 2 goes with Narita. That same index value is implicitly there for the array. It's just not displayed. So one of the biggest differences is that implicit versus explicit index. That does allow some extra functionality with Pandas data frames when you get further into them. And when you have an array, again, two-dimensional, you can still specify by index position the row column position of the particular value you want to return, just like you can using iloc on a data frame. The difference again here being these are explicit index positions. With a data frame, they're implicit on a NumPy array. There might be times where you want that functionality of a data frame. Maybe you want to call the head function, or you want to call the tail function, or maybe you have data in a NumPy array in a data frame and you want to take a column from one and move it to the other. You're going to get errors if you try to merge together a Pandas data frame and a NumPy array, a column from one and the other. You're going to get errors if you try to call head or tail on a NumPy array. So there might be times when you need to move it from one to the other. So there's lots of different methods you can use to switch something from being a NumPy array to becoming a Pandas data frame, or to change a Pandas data frame into a NumPy array, and so on. I won't go through all of them, but I'll just give you one nice little example. If you want to convert our predicted values into a data frame, you just pass that NumPy array, into the Pandas data frame constructor, and it will create a data frame for you. So now I can actually have that same wonderful functionality of the Pandas data frame on my predicted values. So you're going to end up going back and forth a lot between NumPy objects and Pandas objects. So just be prepared. When that happens, you can use type to figure out what they are, and there's lots of great methods out there that'll let you switch back and forth between NumPy and Pandas.
Chances are, staring at a bunch of numbers isn't necessarily going to give you a lot of insight. Sometimes, that's what you need, but a lot of times it's nice to have a picture. The old saying, a picture is worth 1,000 words. I guess it's worth some level of numbers as well. And that's what we want to explore here, is how we can lay down some charts and start to see what's going on with our data. That one big thing that we're going to want to be on the lookout for is some level of correlation in our data. That sometimes we're looking for something that's relatively high level of just, hey, real quick, does X impact Y? Sometimes it's because we want to remove items out of our training data because that could wind up skewing our results. So for example, if we were looking at something where we were trying to predict something and we had both maybe the amount that somebody spent on a plane ticket and their fare class, well, chances are those are going to be pretty tightly correlated, because generally speaking, the more money that you spend, the higher of a class that you're going to wind up with on the plane. So sometimes we need to remove that data, or sometimes we just want to go in and explore and see those types of things. So that's what we're looking for. One way that we can do this is through the use of a scatter plot. A scatter plot is a really common chart type where what's going to happen is a dot is going to be drawn out on your chart. That's me drawing dots. A dot is going to be drawn everywhere on that chart where X meets Y. And so now I can see, based on where all of those dots are, what the values are, what the scatter is, what the full range is of all the values that are going to be on there. It's very useful for then checking correlation between columns. So if you're going to notice that there is that correlation where the value of one changes along with the value of another, then we're going to see that inside of our scatter plot. So if we break this down to a couple of real-world examples, you are going to notice that there's a correlation between, say, car accidents on a particular day and snowfall. But you're probably not going to notice much of a correlation between snowfall and the stock price of Microsoft on any given day. We could, stop here and have a conversation about correlation and causation and so forth. That's a little bit beyond what we're looking for. What we're really looking for today is just, hey, is there correlation? So a couple of scatter plots you can see right there. Correlation, you'll notice that real nice tight band that's going from the lower left towards the upper right. And then no correlation, you'll notice that my values are just simply, well, scattered. And so that's a really nice indicator of what's going on there. We can use Matplotlib to draw out our graphs. So if we have a data frame, we're going to be able to use that to draw everything out. We are going to need the library, so we'll pull that in right there. And then we'll be able to actually draw a chart directly from our data frame. So what I want you to notice about this code block here is the fact that we are, and I'll just go ahead and draw this out here. So what we're going to do is we're going to load up our CSV file. We've already seen how to do that, so not really a whole lot going on there. And now we're going to plot everything out. So we're going to indicate, hey, we want a scatter plot. We're going to indicate what we want the X and the Y values to be. So the X is going to be distance, and then the Y is going to be our arrival delay. You'll notice the color, you'll notice the title. Both of those are pretty straightforward. The one that I want to highlight here is the alpha. What the alpha is going to do, it's a 0 to 1 base number, is it's going to indicate how lightly or how heavily drawn each one of those dots is going to be. By default, the alpha is 1, meaning that's going to be just a completely dark dot. If we lighten that, though, now what we're going to notice is that a single dot is going to be a lighter color. And if there's like two dots that are top of one another, or maybe they're just slightly offset, then what we're going to notice is that it'll get a little darker with 2 dots, and then 3 dots, and then 4 dots, and then 5 dots. So that way, if I'm looking at data where I've got a lot of points that are going to be inside of my chart, and I'm trying to get a better sense of, hey, where are things grouped together, I can do that by setting a lower alpha. So now I'm going to see darker colors where there's more overlap of values. Then we go ahead and call show, and then what will happen is it will then display everything out. And what I want you to notice here, first of all, is the fact that there's not a correlation between distance and arrival delay, which might have been a little bit surprising. I kind of would have figured there would have been some level of correlation, but we can see that there's just dots scattered all over the place. So no real strong correlation there. The other thing that you're going to notice is the fact that we've got just a lot of values really down towards the bottom, so there's just not a lot of delay for a lot of our flights. And those outliers are then just that really faint color there. So it's a really nice way to get an overview of how our data looks. Now, we can also go in and break things down across multiple lines as well. So we don't necessarily have to go directly from the data frame. Maybe we want to be able to break this down into multiple lines, maybe because we want to be able to reuse things, maybe because we want to make it more readable, maybe because we just want a little bit more power, and we just want to be able to control exactly how our chart is going to be laid out. So this will actually do almost the exact same thing. The only difference is the fact that we're going to be using the departure delay and the arrival delay to display everything out. And so now we can see that nice tight correlation there. And we can already start to see, hey, there's an obvious line that's forming there because we've got our departure delay, our arrival delay, and it obviously makes sense that there's a tight correlation. But we also have like a little bit of a, I don't know, like a little something going on over here. So it'd be nice to be able to just slap down a line right across here. So that way I can hopefully better visualize how all of those numbers are coming together. So this is actually where we could use a little bit of linear regression. That linear regression isn't necessarily only used to try and be able to predict values. Sometimes it can be really helpful to be able to just have it draw a line. The name linear there is it's not just a clever name, it's all about being able to draw lines there. So let's take our data and let's feed that then into a linear regression model. And then when we get our value back, now let's go ahead and snap down that red line. So this is really that same data that we saw previously. The only difference is now we've run it through a little bit of linear regression. So the y value, that y predicted, is going to be the prediction of the arrival delay. And that's what's going to give us that nice red line. And then we can use that model to then overlay that on top of our data and see that nice, neat little line. So there, one more time, is a little bit of code. You're going to notice that we're going to draw everything out with that nice red color, and then we're going to create the scatter plot down below where we've got everything laid out in blue. So the end result is going to wind up being a nice, neat little chart here where we've got all of those raw values and then the linear regression model laid right on top of that. Now we can see kind of nice and clearly how it is that our departure delay is impacting our arrival delay. Let's turn our attention to the code so that way we can see all of this in action. Let's get in and take a look at a little bit of code here. So just like before, we're going to bring in our pandas library and we're going to load in that exact same data. So nothing new here. But now what we want to do is we want to start plotting everything out. So we're going to bring in our Matplotlib, and then we're going to plot directly from that data frame. So what I want you to notice here is the fact that we're setting up a scatter chart that we're going to, or scatter plot rather, that we're going to do x as the distance, y as the arrival delay. And when we see this, what we're going to notice is that, give it a moment here, that there's no correlation between those values, that we're seeing kind of a true scatter plot. We've got values scattered everywhere. If we take a look, though, at something that's definitely going to be tied together, which is the departure delay and the arrival delay, now what we're going to see is a different result. Again, give this just a second here, and now we can see that little chart going across. It's really the exact same code. The only thing that we changed was just the XY columns here. So there's everything. Now I'd like to get that neat little red line there slapped down. And I'm going to do that by using a little bit of linear regression. So let's bring in everything for our linear regression here. And I'm not going to dig too deep into this code. You can go check out the prior module where we talked about linear regression. The thing that I want you to notice is that we're going through the exact same steps, that we're dropping the null values, we're setting up our x. So this is the feature. This is what's going to drive the value as the departure delay. We're going to set up the arrival delay as the value we want to predict. That's going to put that on a nice, neat little line for us. And then we're going to execute our regressor and then get the prediction values back. So now I've got all of that inside of the y predict. So now let's build up that chart. So right here, we've got our x test. Let me just type out here real quick. That is going to be the departure delay. And then right here, that y predict, this is now going to be that smoothed out arrival delay there. That's going to be that neat little line that the linear regression model created for us. So that's going to be our x and our y respectively. And so now I can run that, and there is that neat little red line that we were just talking about. Let's say I want to see that on top of the scatter plot data. Well, that's right here. So what you're going to notice is one more time we're plotting everything out just like we did before. We're setting up our scatter plot just like we did before. The main difference really is just the fact that we're calling both plot and scatter here. So now when we call show down at the very bottom, it's going to put both onto one nice, neat little graph. And now we can see that red line going across all of our scattered values. And so that's how we can use our scatter plot to get a real good sense of what's going on with our data. So we can see whether or not there's correlation, and in turn, we can even use linear regression just to get a nice, neat little line that we can slap down to be able to better get a sense for what's going on with our data. Well, if you made it this far, then I guess the last thing that we have to say at this point is thank you. We also want to encourage you to get in and really start playing with all the different tips, tricks, and tools that we've demoed here.
Yeah, so go out. Now is a perfect time you've got some of those Python skills ready. Now is a perfect time to go look for some data science tutorials. Check out some of the stuff on Microsoft Learn at docs.microsoft.com, some of the quick starts. You can find some really great tutorials to get started with machine learning, training models, and it should be a little easier now because you already know some of the code.
Yeah, so if you're looking for like specific spots to go in and start looking, check out the GitHub repository that we've linked to. You're going to notice that we've curated a handful of like kind of nice next steps in how you can continue growing from there. So now's the perfect time. Start writing some code. Thanks again.
Thanks again. See you next time.